Welcome to aminacademy.com. In Laplace Transform, let us discuss about properties of inverse Laplace Transform, that multiplication and division by s. Here, first multiplication by s. Here, if inverse Laplace transform of f of s equal f of t and f of 0 equals 0, then inverse Laplace transform of s into f of s equal f dash of t, that is derivative of f of t. Here the product, that is s, is multiplied with f of s here. Thus multiplication by s has the effect of differentiability f of t. It is, if you multiply with inverse function of inverse Laplace transform of f of x, that is s you are multiplying, it affects the differentiability of f of t. Or we can say inverse Laplace transform of s into f of s equal f dash of t plus f of 0 into delta t. Where delta t is the Dirac delta function or unit impulse function or unit impulse function. Here we'll do some example. Here inverse Laplace transform of 1 over s square plus 1, we know that it is sine t, and f of t, that is sine 0 equals 0, we know that. Then we can say inverse Laplace transform of s over, that is multiply with s factor s square plus 1 equal d by dt of sine t equal cos t. That means inverse Laplace transform of 1 over s square plus 1, we can say it is cos t. In general, we can say inverse Laplace transform of s power n f of s, where n equal 2, 3, 4 like. That means before we are using only s multiplication, now we are multiplying with s power n. Then or possible, these are possible by using s power n. Next, division by division by S vector. So that here, if inverse Laplace transform of f of s equal f of t, then inverse Laplace transform of f of s over s equal integral 0 to 1 f of u du from 0 to here. Thus division by s or multiplication by 1 over s has the effect of integrating f of t from 0 to t. For example, inverse Laplace transform of 1 over s squared plus 4 equal, you know that, half sine 2t. By using this division that is Laplace transform of 1 over s into s squared plus 4, that is, we are dividing this function with s, which gives by this property 0 to 1 half sine 2u du, which is further equal 1 by 4. Sine 2u is taken as 1 minus, here sine 2 integration is 1 minus cos 2t. That means we are using 0 to t, integral 0 to t. That means we got inverse Laplace transform of 1 over s into s square plus 4 is 1 by 4 1 minus cos 2t. In general, you can say inverse Laplace transform of f of s over s power n, where n equal to 2, 3, 4 are possible. Next property is the convolution property. Convolution here, if inverse Laplace transform of f of s equals f of t and inverse Laplace transform of g of s equals g of t, then you can say inverse Laplace transform of f of s into g of s equals integral 0 to t f of u into g of t minus u du, which is equal f star g, where we can say f star g, the convolution or Faltung of f and g, the convolution or Faltung third term of f and g, and the theorem is called the convolution theorem or property. Here, for example, inverse Laplace transform of 1 over s minus 1 equals e power t, we know that, and inverse Laplace transform of 1 over s minus 2 equals e power 2t. By convolution property, we have inverse Laplace transform of 1 over s minus 1 into s minus 2, which is equal 0 to integral 0 to t by using convolution theorem, e power t into e power 2 into t minus u du, which is equal integration e power 2t minus e power t. We have done. Please subscribe our YouTube channel.